Good morning, everybody. A warm welcome to day 2 of Zeitgeist. Can you hear me okay? Great, great. So please clap your hands if you had a good time last night. Clap louder if you had a really good time last night. Reiner. Great. So today is all about AI. You'll get a chance to kick the tires, see what's under the hood. If you have any questions, if something excites you, if something worries you, you'll be able to ask in a Ask Me Anything Google session later on. So today is the day. And we will go from the wow of AI to the how of AI. Yesterday, you heard some examples. For example, Matt talked about Google Translate. And I remember the days when it was the butt of jokes in my native Turkish. We used to make fun of it. It was so bad. And that was just several years ago, my Turkish friends laughing here. But today, it's fluent in Turkish, and it's fluent in 100 languages. And Matt talked about how it's going to go to 1,000 languages. And then yesterday, again, Yossi talked about diabetic retinopathy and how, thanks to that, 250,000 people got early scanning in a way that they wouldn't have been able to before because there aren't enough doctors. And this is a great way to detect early signs of blindness. But then, Faisal asked Thierry Henry, do you think AI makes you a better player? And Thierry Henry said, well, it understands many things, but it doesn't understand me. And I think he has a big point there. What excites me, actually, is not AI. I mean, I am a geek, but it's not AI or technology. What really excites me is what people do with AI, whether it's detecting floods, whether it's detecting fires, early detection of fires and saving lives, whether it's using it to improve the air quality in a city or to communicate with people that they don't speak the language of. That's what really, really excites me. And in the next hour and a half, you'll hear many examples of that. And why this excites me as someone working at Google is this AI is in the hands of billions of people who we're lucky enough to have using our products every day, hundreds or millions of businesses who are, again, using these products every day in more than 100 countries. And just thinking about the impact, the positive impact that that can have on their maximizing their potential or overall, that's what really excites me. And so when I talk like this, my friends go, right, you know, you're so excited about AI. We get it, although it's the people I'm excited about. But anyway, they say, what should my children study in college? And my answer to that is the same thing I tell my daughter, Yeshim, who is in college, and she's a singer. She's studying music. And what I say is, do what you love, strive to be the best at it, and make sure that you're using the latest technology better, faster, before, more than anyone else. And I think that applies to us all. So, big questions, hairy challenges. I really hope you had your morning coffee. I can't think of a better person than Professor Hannah Fry to take us through the next hour and a half. She is a math whiz. She is a TV broadcaster. She is an academician. With that, please give a warm welcome to Professor Hannah Fry. Thank you.
Thank you very much. So yes, I am Hannah Fry. It's possible that you have come across the work that I do making science documentaries for the BBC, but just to reassure you that you're in safe hands, I'm also a professor of mathematics and the president of the Institute of Mathematics, right? And I'm also, given the lineup that you've got today, going to be the least intelligent person standing on this stage, right? And that really is saying something. Now, I know that over the last couple of days, you have had the chance to see the power of Google AI to create new forms of musical expression, to create innovative solutions for tackling things like the climate crisis. And Gemini now is really, I think, poised to push the boundaries of what is possible with artificial intelligence, new frontiers in human-AI collaboration. And the idea here really is to have an AI that seamlessly integrates into our lives, really interacting with us in ways that can enhance our creativity and productivity. And here to tell you a bit more about that and the work of DeepMind is Joelle Barral from Google DeepMind. Please give her a warm round of applause.
Thank you, Hannah. Good morning, everyone. It's really great to be here. My name is Joelle Barral. I'm a Senior Director of Research with Google DeepMind, our global world-class AI research lab. And I'm here today to help you appreciate our approach to AI innovation at Google, our bold and responsible approach. I've had the pleasure of spending the last decade at Alphabet, where I've been working on cutting-edge technology with AI on the forefront of our products and our research. And if there's one thing you remember from my talk this morning, you all look quite awake, but remember that one thing is that the best is yet to come. So before I share with you some of our latest outputs, I wanted to get back to our DNA. The paper you see here on information retrieval by Larry and Sergey, our co-founders, is really at the core of what we do. We are grounded in research. It got us on our mission to organize the world's information and make it universally accessible and useful. I like to define AI, artificial intelligence, as the science of making machine learn. Learn, that is, acquire new information, new knowledge. And by that definition, you see why AI is really close to our mission. And no wonder we became an AI-first company in 2016. For doing machine learning and getting AI to perform the way it does today, you need three ingredients. You need architecture, the neural networks, the algorithms that are capable of crunching a lot of data. You need a lot of data to train those models, those algorithms. And you need a lot of compute, both to ingest that data, train the models, and also serve them. And that's how you get them to do what they're capable of doing today, what seemed impossible just a few years ago. And I would like to illustrate that point. Here, the image on the left shows you what we started getting in 2014. And from our research labs, when we got that picture, we were blown away. That looked like a really incredible picture. Many of our researchers have spent their entire lives working on those problems, and they really thought that was it. Like, we were done. Now we're capable of doing it. Of course, now you all take for granted that we can generate images like the one on the right, photorealistic, within seconds. It works, and it works every single time. How did we get there? At Google DeepMind, our research labs have built many of the foundations of the AI industry, starting with games and what we call reinforcement learning. Games are a really good proving ground to develop and test algorithms. That's because they provide a closed environment where we control all the variables, and there's a clear goal. And so it's really a very useful sandbox, very useful testbed to build algorithms. We started with a simple game, Atari, and then somewhat famously mastered Go and became, developed the first algorithm that was capable of winning against the best human beings. And now we're mastering old board games and getting into more complex gaming endeavors in virtual worlds. In parallel to all of that innovation on algorithms with reinforcement learning, we've also built the foundations of the generative AI revolution you're seeing today. From the transformer paper, which is really a key algorithm that makes it efficient to train algorithm at scale, we built the first large language models based on transformers, which we call bidirectional encoder representations from transformers, and then the series of large language models, BERT, T5, Lambda, that Sundar, our CEO, presented at Google I/O a couple of years ago, Palm, Bard. There's actually in Twitter, so if you follow carefully, maybe you'll tell me at the end. And from all of those models, we've now entered the Gemini era. Gemini is our largest, most capable model. it's multimodal from the ground up, I want to say. So it's been designed with multimodality in mind, which means that it can understand text, but it can also understand audio, video, code, etc. It's also the model that has the largest token window, the largest context window of 1 million token. And a token is a unit, a representation of text, meaning a word or a punctuation mark can be a token. It's how we divide things up to then process it. So 1 million token window means that the model can process that much information each time it is generating text to answer a particular question. So in some ways, it's what the model keeps in mind as it is answering a question. So this is the largest token window of any large language model, and it's really unlocking amazing capabilities. And I hope you'll all stay tuned for upcoming news later today at I/O. So I want to give you a concrete example. In this 44-minute Buster Kitten movie, the context window here, given it's 44 minutes, is roughly 700,000 token. And here, we ask the model to find the moment when a piece of paper is removed from the person's pocket and tell me some key information on it with a time code. So we're asking a pretty general question. And we want the time code so that we can check that the model is doing the right thing. And so you can see here, the model is thinking, is processing that question. And after about a minute, it's been sped up. It tells us that at timestamp 12:01, there is a piece of paper removed from a person's pocket. It's a pawn ticket from Goldman, et cetera, dated. And then we can jump to that particular piece, and here's what we see in the movie. We look at that ticket, and it says precisely that it has this information. So I picked this example because if we look at it for a minute, it's absolutely mind-blowing to now have models that have never been trained for that particular piece of information. A couple of years ago, 2018 or so, we had already ways to interrogate videos and find action moments. For example, when is someone blowing candles in a birthday movie? But we had to have a finite dictionary of those moments, right? We have to predefine those moments and then train our videos specifically to do that. Here, of course, we've never trained a model to recognize pieces of paper taken out of people's pockets, right? That's not something we would label and then train models on. So that's an example really where you see the power of those models that are really capable of doing complex tasks they've never been specifically trained on and are really able to go through lots and lots of data, a full movie, to pull out a particular piece of information. So that gives you an idea of Gemini as our most capable and most flexible model. It's also more than a model. It's really our biggest research and engineering endeavor ever. And this is why I'm really convinced that the best is yet to come. AI has the potential to help us solve some of the most fundamental problems facing humanity, from curing diseases to tackling climate change. Our researchers recognized that early on, and that's why they defined our AI principles as early as 2018. And the one important thing about those principles is precisely that it's putting social benefit at the center. The first principle is that AI has to be socially beneficial. And that's also why, now that we are on our way to unlock that potential way beyond just large language models, those principles are at the backbone of everything we do in research. So I want to illustrate where and how AI will have enormous potential for society with a handful of examples. You'll hear later today from Anna in the life sciences how AlphaFold is unlocking a lot of potential in biology and redefining the practice of biology, first by having predicted the 3D structure of proteins and now going beyond just proteins to really understanding what makes up biology. Yossi yesterday shared with you a handful of examples in transportation and with contrails, for example, where we're able to reduce the impact of the aviation industry on global warming. A contrail blocks radiation from the sun going to Earth, but also blocks it the other way around. And the net effect is actually that it increases global warming. So by changing some of the routes, we're able to dramatically reduce the impact of contrails on global warming. I like that example because it shows you also that when you pick the right example to crack, to fix with AI, you get to important, scalable impact on those fundamental issues, right? So it's really identifying a problem that will have outsized impact on some of our biggest challenges. And then the last example here is something we worked on with the Swiss Plasma Center on fusion. So fusion has long been perceived as being the holy grail of energy. And to do it well, you need to really master your plasma inside tokamaks. It's not an easy problem. The plasma is hotter than the sun. You don't want it to touch the walls. So you need to control that plasma by tuning the magnetic field, like shaping the magnetic field, by adjusting the voltage in all of the coils that are making up that tokamak. So working with the Swiss Plasma Center, we shaped that problem as a reinforcement learning problem and leveraged algorithms to get to better control and the best shape that can really help understand fusion and get to the most optimal shape of our magnetic field. And those examples are really illustrative of the fact that many believe AI will have the biggest impact in the sciences. Let me double-click quickly on two specific examples, also to help you appreciate our perspective on those research endeavors in the sciences. So if you think about weather, which impacts all of us daily, we've built two models, one that can help us predict 24-hour regional high spatial and temporal resolution surface variables, and another one that looks at a 10-day forecast, global variables, which is illustrated here, surface and atmospheric variables. We've published that work both in Science and Nature Communications, and we're also making those predictions available through our products wherever weather matters, for example, in search. So it's both pushing the state of the art, pushing the art of the possible through scientific publications, and having impact for our users. And my second and last example is in healthcare, where we trained our model to answer multiple choice questions for US medical exams. The pass mark for a doctor is typically around 60%. Our first model was at 67%, demonstrating that you can do better than the average student. For example, to answer questions like the one shown here, what are the first warning signs of pneumonia, for example? And then very quickly, we continued training models, and we got to 85% accuracy, which means at the level of experts. And again, here we did both. We published that work in Nature, and we made those models available to our customers through MedLM, a family of foundational models fine-tuned for the healthcare industry. And we very recently published two papers called Gemini that are, again, leveraging Gemini, which you saw earlier, for healthcare. And to echo that video example, those papers are showing how similarly in surgical videos, you can now identify precisely something that's called critical views of safety. So in gallbladder removal, cholecystectomy, it's very important for the surgeon to make sure that they've identified structures properly before they continue so that they don't cut something they shouldn't cut. And so the exact same technology is really leveraged to do that automatically and augment what a surgeon can do without supervision. So we're living through a moment of rapid, unprecedented change. Today I've focused on the science, but it's really critical for people to understand and embrace the potential of AI. We push the frontiers of AI innovation for the benefit of our users. The best is yet to come. Thank you very much.